not open source, like how it's called.
Shareware?
No, not shareware. Indie project. Yeah, in United. After I leave my room. There's a studio, little one, of six people.
Not the Mail.ru.
Huh?
Not the Mail.ru.
No, after it.
How was it working in Mail.ru?
In what?
How was it? Like, how did it felt working in Mail.ru?
Quite nice, quite smart people, big team, about 150 developers exactly in the team of Skyforge, but lack of management and almost all of management based on the smart people who is working in team and self-management. Management itself sometimes get some strange decisions. So, like you know, after a month's meeting, when they say, yeah, people were great, we gained $1 more million by this month, and we bought all of you a bunch of bananas. It's a kitchen, go to it, yeah. But no, it was funny. It was a company of smart developers and experienced ones who can always learn from.
This paradigm is actually very good for server-side development, and I will show a few examples.
I'm eager to look. Maybe I know it, but I know the exact name, like ECS for it.
Well, so we are ready to start. If your class hierarchies are so complex that your head starts aching and adding new functionality to your games feels more like a chore rather than a working process, you've come to the right place. In this talk, I promise I will teach you to make how to make perfect architecture for your games. So you'll be able to start enjoying life again. But first, a few words about myself, who I am and what I'm doing here. This slide contains a few projects, most of them released, and well, the most recent one that has been released was CarX Highway Racing. I was working there as a part of the CarX technology team, and last half of year working there, I was a lead programmer. But this July 2017, I have decided to fire myself, and we have decided to make another game with a few colleagues from that company. And so this game that we were making and still making is going to be our main example today. So this is a Road Trip Overdrive. It's a side-scrolling runner about a fast-moving car that jumps in the air, and while it's in the air, it does some stunts, and these stunts compose into quests which we have to complete. So the core of the game is bound to making interesting and diverse stunts. So the main problem of this game is enabling adding new stunts easily. And as we all know, game development is a very iterative process where by the end of the development, the feature list from the starting game development document is completely different. So we have to be able to frequently add new stunts, change the stunts that we have added, to delete stunts very easily. And usually it's done by making some kind of managers. They say that if you don't know what the class should be responsible for, call it a manager. So we are making a lot of managers, just like in real life. If you don't know what the person is doing, call him a manager. So we have a lot of managers which contain a lot of logic about these stunts. It's all put in one class. A lot of events, a lot of intertwining logic with other parts of the system, and by the end of the development it makes it very hard to add functionality, because at first it feels like we have a lot of control over it, but in the end it starts looking a bit like this, where no one can really make anything out of that. So every developer, at least a few times in his or her career, will be presented before a choice that we should need to rewrite the whole architecture. Who has experienced something like that already? Of course, it's all natural, and people either start rewriting. Oh, I forgot, there is a very cool picture where there is a guy who looks to the left and the same guy looks to the right, and the caption says, I've learned so much, start over. I've learned so much, start over. And this whole vicious circle doesn't let you finish a game. But what if we were able to just write our games without needing to overthink about architecture, to do the stuff that the game is all about, and not want to rewrite the whole architecture in a half a year of development? So let's try to imagine some perfect system that will allow us to do it. Let's say that we have to put our stunt logic in separate classes. So these classes only handle the logic that is specific to the stunt. And as stunts by themselves are usually very trivial to implement, these classes will contain only about 5 or 10 lines of code that is going to be running. And this is an example, and we will return to this a bit later. But right now I want to focus on a fact that it actually has only like 4 lines of active code, and the remaining stuff is just boilerplate, like curly braces and class names and stuff. So we implement all those small little classes with stunt logic and put them in some common list. So we have like 3 different stunts by the start of our development. Our game designer said that he wants us to implement 3 different stunts. So we did that, put that in some common list, and then he approached us again and says that we need to implement 2 more stunts, like close call and upside down. And it's a really natural process because games, as I said, are really iterative. And as we have implemented our stunts in separate classes, we can add 2 more separate classes, and it won't break anything. Well, at least ideally it won't break anything, and we will see how it can be useful. And we have implemented them too. They have taken like 5-10 lines of code, and we have added them to our common list of systems. And we will check out what the systems are in just a second. And this is what Entity Component System is about. Welcome. But for this cunning trick to work, we have to put things upside down. We don't rely on behavior. We say that the data that our game operates on goes first. So the data is more important than the behavior. So it's the data that controls the whole process of the game, not the behavior itself. So the main part of the game, so the data becomes the main part of the game. And the data is stored inside entities and components. Components are just atomic piece of data without any logic, and it's crucial to know that it shouldn't have any logic at all. So, for example, if we have components in Unity, they both have data and logic, and this is the main difference from it. So our components is only data, without any logic. This is an example of a stun component. Stun type can be a simple enum or some string identifier, so we can so we know which stunt we are dealing with. Entity is just a set of components, and the components that are put on the entity identify it as an entity of some type. So we can, for example, look for entities with a stunt component, and we know that this entity should probably represent stunt. So we can query other entities for other components, like we can query all the stunt entities and to put some score for the, let's say we want to restore fuel for completing stunts. Or we can complete a quest if the quest is interested in the stunt. So entities are a set of components which we can query on and which we can act on. And this is a more complex example of an entity with 3 components, and we can say that this entity must be some sort of a car, because it has a runtime car data component, and it identifies it as some sort of a car, and the car data is just some settings that our game designers set, like mass, spring, stiffness, and so on. But unfortunately, we can't write games without logic. It would be nice if we were able to just put some data in a bucket and it will just magically work, but it doesn't. Unfortunately, works like that. So the only place that logic can go to is systems. And as I've said, logic is not a hero anymore. It's more like an actor that plays a secondary role, because as systems don't have any data and the data is stored in components and entities, we can just turn off all the systems and change the data by hand. So if we turn off some system, we can fake it by using change data that we entering by hand. Or we can write another system that does the same, but in a slightly different way. So we have a set of components and different systems that are interested in different components. And as systems don't know anything about each other, they need to work with each other in some way. And this component set, or rather entities with components, becomes some sort of a mailbox between the systems. So some systems put something into the mailbox, other systems may be interested in that data, they see that something has happened in the mailbox with the data, something has changed, they see this changed data, they can either delete something or add something or replace some values on the data. So this whole interreactive thing that goes not through the direct links between the systems or between objects like we are used to in object-oriented design. We are not calling methods directly. We just iterate on some data and hope that our changes will be picked up by some other system. So most commonly, components are used by different systems, like in this case. And as systems don't know anything about each other, we can safely remove systems from the game without worrying that it will break. Because, as I've said, systems don't know about each other. They just know that if the data is changing in some way, it reacts to that and can change some values. For example, we can turn off the fuel burning system. So the fuel doesn't burn, and the other part of the game knows nothing about it. It just sees that fuel somehow doesn't change, and the UI updates appropriately because it just represents and shows the same value every frame. So it makes it very easy to debug the game. Just turn off some systems that, for example, damage a system that kills the player, and you can play a game without it. And this is a very good application of this common mailbox of data. So this common change in state, this our mailbox becomes a moving force between systems, some sort of air between the systems. So as we have our data completely separated from the logic, we can just turn off the logic of our app and see what's going on just by looking on the data. And it makes it very easy to implement, like saving and loading stuff, because it's usually not very trivial, because you have to unroll the object-oriented hierarchy and put some data there. While if you have data already in a serializable state, you can just save it and then load it. And the loading process is also very simple, because you just turn off all the systems, replace all the data of your game with the loaded one, and fire up the systems again. They see that the data has changed and behave appropriately, so nothing breaks. So state really becomes everything. And I really like the quote by Maxim Zaks. It's one of the developers of Entitest library, that data model is a state, events are state, and services and dependencies are also state. So what is state?
Everything.
Everything. And a few examples just so you see it in action, or sort of in action. We have our stun component, which we have seen already, and a big air system that just checks whether or not the player is higher than the current track height, plus some setting for this stunt. And if it is, we just create a new entity with a stunt and set it as a big air stunt. Add it to the common list of systems. Another example, audio effect component. So, for example, if we need to play an audio effect, we create an entity with the clip data, and the clip data is just some pointers to the audio clip, its name, its volume, and its length. And the system that works something like this. It's a very simple sound effect playing system that creates an audio source for every new entity that comes into it. So it listens to the new entities with the sound effect component, creates a new audio source, plays it through it, and destroys an audio source after that. Don't forget to add your system to the common list. And the next step would be to add some sort of a pooling component that will store these audio sources, so we don't need to create a new one every time. Another component. So as you can see, components can hold no fields at all, so it becomes like some sort of a flag component. So if this component lies on an entity, we know that this entity has to be something, or something should be happening. So components without fields are possible too. And we have a boost component that has a value which is a boost fuel tank. So it's like a fuel, but while it's greater than 0, we know that we are boosting. And a system that says throttling by checking current boost, whether the entity has boost and whether the fuel value is greater than 0. In this case, we say that the car is throttling and not braking. Don't forget to add a system to the common list. And a lot of questions rise when people start thinking about hooking up UI to this entity component system, because game logic is some sort of a natural to comprehend, but the UI seems a bit off in this situation. And I assure you that there's absolutely no difference between handling UI events and game logic. For example, we have an action command with some sort of an identifier. It can be a string, an enum, or just about everything that works in your case. And some system that, for example, checks for the pause action and sets some pause entity, puts a pause component to some entity, so other system that can actually pause it. So the business logic system, it checks for the new entities with the pause component and pauses the game. And don't forget to add to the common list. So this cycle of feature addition covers almost like 99% of all the cases. So we first start off with the data. We think of which components will work in our case. We don't think of how it should work yet. After that, we create some systems that will actually make some work for it to be visible, adding systems to some common list and checking that actually everything is happening. And it makes the test-driven development, which is very uncommon in game development, a trivial task. Who maybe have tried writing tests for the games? How was the experience?
Not for
Yes, it's not very suited because, well, the game logic is usually very tied to some physics or some other stuff that is really hard to test right. But if you will put your hands on some book on test-driven development in ECS, it will most likely have just one page with 3 lines. Is prepare state. We're just putting all the entities with all the data that we need. Run our system or systems, and then just check the results. As the data is lying openly, we can check whether or not our systems have changed it correctly. And this algorithm covers all test cases for the game logic, starting from the smallest unit testing, where we test the systems, separate systems or separate systems of parts. And we also can write a massive integrational test that checks whether or not our game is actually possible. So after tweaking some parameters, we can run an integrational test, and it will try to play the game to the end and say that whether it's possible to solve it or to play to the end or not. Okay, sounds good, right? What's it good for? And as a lot of game developers are actually casual game developers, this was, and it's my first slide, because Match 3 is a perfect example of applying this architectural pattern. As Match 3 games are very easy to make deterministic, I've seen some examples on where developers have put touch remembering logic, and if something strange has happened during the gameplay, they just sent it to the server, and the data was just where and in which time the user has touched which piece of the board. And if some bug happens or something else strange, a developer can just download this replay data and replay it on a local machine. So it's very easy. Another example is strategy game, and not just this Clash of Clans type, but just any type of strategy game, because in this case of entity component system, we are by default one level higher from controlling all units separately. So in object-oriented design, you would most likely have some sort of a unit class which has some commands like go here, go there, attack this, and it makes it harder to control all the units as a squad. But in ECS, this squad control is implemented by default because you don't usually start with tweaking separate entities. You just query them in array and, for example, can order a squad to attack some building, and the logic that is in the system will guide those units to their needed locations. So it's also very easy, and it's also makes it very easy to implement these kind of games deterministically. So after the match, we can just run the whole half an hour game in like half a second and check that no one has cheated. So we can surely say that we can add some rewards for the game. Another great example is trading cards game, because by default it's very unfriendly for the object-oriented design, because who plays like something like Hearthstone, or like with every new deck they think of some new mechanics that were, I don't know how they have thought about them, but they are completely different from what they had before. And this type of architecture should really support this kind of random addition of features that no one has thought of at the beginning of the design process. And there is a company called DevGAMM which have implemented a whole engine for their World of Tank Blitz using this principle, and they have rewritten it 2 or 3 times until they have stumbled upon this ECS pattern. And after that, after they have changed their underlying code to represent ECS pattern, they have never rewritten it again. And the guys from DevGAMM that have made this engine were actually in the audience while I was giving the talk in Minsk, and they have said that ECS is the best. We will say everyone that ECS is the best. Their engine is open source, it's in C++, and it's mainly on mobiles. It doesn't have any documentation, but if you are really interested, it won't stop you. And one very common question is whether it's possible to, or rather feasible to, create a first-person online shooter with this paradigm. Who knows an example of this?
I think it's possible to create a World of Tank Blitz. First-person shooter is not so much different from it.
Well, to your mind maybe, but not to everyone's mind. So who knows a concrete example of this? No? And Blizzard have quite a few talks about this on the closed GDC section, where they tell about their ECS approach, and they have said that this approach have enabled them to quickly iterate on new features, because every hero has unique mechanics, and this approach, this combinational and how's it called? Well, strategizing approach with ECS enabled them to add new features easily, and they are continuing to do that. But wait, there's more. Every game has some sort of hot data that is processed in huge chunks every frame. Well, most games have that. And using ECS enables us to more easily increase performance when dealing with that kind of data. Because usual object-oriented approach, or like in this case, component-oriented design, where our components are scattered all over the memory, it makes it very hard for the CPU to put everything in cache, and CPUs don't really like going back and forward between the main memory and doing some actual stuff, processing. So this design makes it very hard to put things in linear order, so the processor can really benefit from its caching capabilities. While ECS approach enables us, well, if it's done in that way, to store data as data is just data without logic in linear arrays and process them in sequences. So CPUs really like that, and they start working faster than you have expected of them, really, because for example, the most dreaded operation is the squaring root operation, which is considered to be very slow, and every developer should avoid it at any cost. It actually takes 10 times less time than fetching some data from main memory. So this is the dreaded operation, but we are still making things that take much more time than that. And this enables really to not just increase performance, but to decrease heating of the CPU, because it works in a more efficient way, and it can really stall for the end of the frame if it's done for everything that was needed to be done. So it reduces power consumption and heating on mobile devices. And this is exactly what Unity does right now. I bet someone has watched their Unite talks where they have talked about it, no?
Yeah, of course.
And what have they shown there?
Probably I can watch the ECS, talk about they're right now very heavily concentrated on optimization for all the platforms, and with this, have you seen the add-on films?
Yes.
Yeah, and they want to show that with such a perfect graphics, they can still feed the view of mobile devices.
Well, Unity actually does this performance-first approach right now. They not only use this linear storage practice, but also trying to make safe multi-threading easier, because these arrays, as they are linear, they can be accessed in chunks by different processor cores, so it makes it easier to multi-thread code. And what about the architecture first approach? I can advise you try Entitas if you are using Unity or C#, just plain C#, or Objective-C or Swift for iOS platformers. It has a really active chat of users who are very helpful, and I also hang in that chat a lot too, and I also hope that I'm one of those helpful people. And before the presentation, I have asked a few experienced and novice Entitas users to give some feedback on the Entitas and ECS approach in general, and this is what I got. I really like Entitas. There is really no point in not using it if you are using C#. We are currently working for over ½ a year on the project, and I would say that I've never felt like we could change stuff that freely. And this is about that architecture rewriting cat that we have seen at the beginning. And there was an interesting story with one user this July, so about ½ a year ago. A guy there was some sort of experimental practice with multi-threading in Entitas, and some user told that we are experimenting with Entitas right now, and using Entitas would make code harder to multi-thread. We are currently considering modifying Entitas or subtly discarding it. And just a few weeks before the November stock, this guy showed up again, and I was very lucky that I was able to get to him, and I have asked whether or not they have discarded entities, and this is what he said. We have used entities, and we are glad we did. I really enjoy working with it. So they have liked it so much that they just discarded their plans for multi-threading because the performance was more than enough for their case. But ECS also has some downsides regarding to it. Like projects were planned to work in collaboration with other client developers, and they strictly refused to learn new technology, and we couldn't agree on future work. And I myself see a lot of skepticism about ECS lately. Maybe because it maybe looks a bit raw or immature, but really the first appearance of this happened in the Thief the Dark Project game, which was released back in the 1998. And unfortunately, the slides from there, some sort of internal presentations, were released just a few years ago, and no one has even knew that they were actually the first ones that have decided to use that approach. And besides, future is here already. You won't get anywhere anyway in any case. So well, what about the ECS itself? I've seen a lot of reviews on the paradigm, and there are really no complaints about the paradigm itself. It's more about tooling and APIs and implementations, but the tools are usually get better as the time passes. So as the practice of the Blizzard and Wargaming and Unity pushes this paradigm too, I can safely say that this approach would be an approach by default during the next 5 or 10 years. And I'm really interested whether or not that will be true, because I make a huge bet on it. So I think that the experience of these big companies and a lot of small companies show that this approach will be very popular in future. So why do you need to wait 5 years when you can start using it now? That's it.
Thank you. Can I ask questions?
Yes.
Do you have problems with prioritizing the systems, as I understand?
Oh yes. This approach, using this paradigm, we have to ensure that we are the ones that order the system. So the system is are executed in a known order in which we put them. So, for example, if we have a UI example, so all UI firing events will be put somewhere at the start of the frame. Then after that, we know that every event that could have occurred actually occurred. After that, some handlers of these events go, and after that, in the very end, as we probably won't need this event in the next frame, we have a system that destroys it if no one has consumed it. So the event order is very strict, and we are the one that controlling it. And Unity actually, this approach is actually implemented in entities, but Unity actually tries making it automatic. So if, for example, you say that you are interested in these kind of entities, and there are some systems that make these entities with these components, it tries to put them in such order that systems that make entities execute earlier than those who consume it. So they are trying to make it automatic, and I'm not sure whether or not it's a right thing or not.
So it's like dependency ordering, they're making it automatically.
Well, for example, if you have a system that
Just writing dependencies, that this component depends on that component events and so on.
it's
And
rather
they
than
are stuff.
putting some, for example, well, in ECS there is a notion of groups. So, for example, you can have a group of components that you are interested in, and you say that I'm interested in all entities with both fuel and boost components, and in entities you are the one responsible for putting this system actually where it needs to, while Unity tries parsing that data, like which systems depends on which groups, and they put those systems after those who can possibly make those kind of
We're
entities.
consuming and producing.
Yes, so they are making it automatic while it's possible to like do it by hand. I'm very used to putting systems by ordering by hand.
So every subsystem ticking every tick. Yeah? It's not subscribing and event emitting.
No, it actually depends on implementation. If you need some,
Just on
if
implementation.
you need systems like which tick every frame, for example, some timer or something, you can call them every visual frame of the game. And if you need to just react on some changes, like most of the systems are, you just subscribe to the groups and you get like some kind of notifications. They are not immediate, not like callbacks or events. They are.
Maybe just Boolean flags, is it ticking or not, and just then tick, check.
Well, in
It's not
entities,
reactive system where you react.
reactive system will react when some new data is put in the common mailbox. So if it sees some data, if it sees that some entities appeared in the group or some entities were removed from the group, it will fire some logic. So it's not ticking every frame, unlike like execute systems. But you can put execute systems, like for example, if you need to tick on timers. So you just put an execute system that reduces the timer, and this by hand calling approach actually very useful for server-side validation, because while the game may take like for example 200 frames for some action to complete, you can call these 2000 iterations in like 0.0 second, 0.01 second on a server to check. So you can call execute whenever you want, so more than once a frame. And about the server side, there is a I will put a link to the slides. It's here. You can write it down, and there are a few blogs on using ECS approach in server-side development, and there is a site called tmachine.org. It's a very popular site regarding ECS, and the guy there who has done a lot of Java development for the MMO games, he said that, well, he has a quite huge set of articles on ECS regarding to the server-side development of the games.
How is it different from pure MVC approach when you have entity as a model and some controllers as you subsystems and view like and subscribe to the data?
Well, what can you say yourself about it?
Now for me is that in the MVC it's mainly one controller at a time. You have reacting to the data.
Well, in pure
implementation differences, not
in
very much.
in pure MVC, you still have some sort of dependency injection and separation of concerns. Like for example, you have your proxies that get access to the data, and you should only access data through the proxies, and you have views that only responsible for rendering. And the main difference is that in ECS, this system is not hierarchical like in pure MVC. Like you have a lot of interfaces and interconnected mediators which contain one another. They are rather very flat, so every system is on the same level of responsibility. And in pure MVC, for example, if you turn off some, for example, some proxy, Well, I'm not sure if that would be a good example. Well, for the most part, you cannot just take out one part of the system, for example, and it will continue working, because this part, that actual part of the system relies on some other parts. While here you can just turn off the logic and still see the data, because, for example, in that MVC approach, some data actually, like internal view data, is stored in the view. So it's not everything in the model layer, in the proxies layer. So
less coupling, yeah.
a lot less coupling, so it's decoupled by default. As I've said, it becomes very easy to unit test.
It's very suitable for games where you have only public data.
Yes, if you are developing,
but
yes.
if you're a business developer, you have to.
Well, I'm not sure if it's possible to write a business application that should be accessed by other developers, because this is what object-oriented approach was implemented. So we have some public API and internal data that we know that we can safely. Yes, but this approach won't let you have that level of encapsulation. So, and it's not needed in games, because I usually see a lot of people trying to put some restrictions on component getting. So how do I create a component that I can only get data from? And I say, how do you want to set its value first? And they say, oh, right, I don't know how would I set its value. So if you are making a game, you are the one responsible for the data. It's very very programmer friendly, let's say, because as it doesn't contain any large class hierarchies, it won't require you to split them apart when they start looking ugly, because everything is on the same level. Yes?
Do we call them like naming do we call them kind of same components with same functionality, I mean data, different names, or is what's like general one? I mean, we have boosting and increasing.
Yes, you can compose that if you see that some part of the system can be reused. For example, yes. Remove.
You could have two systems that do kind of the same thing, like increasing or boosting or something. So we just discard one of them, or what's all name.
Yeah, it's completely possible. If you see that some components do similar data, we can rather either split them apart to make systems behave on that.
So it's also for developers, friendliness and so on, or
About
well, I mean, we said just now ECS is friendly.
developers friendly, yes.
In this case, we have two different functions, functionalities that is called what I call different, or we have one general, well, like general named one.
Well, it depends on the case. I'm not sure I'm following you, but if it can be made general, it should be made general. But well, sometimes there is a problem where several developers starting making some kind of same things, and they actually need to know about other components, and this is where this approach starts showing some of its bad sides. But it's easily mitigated using some static analysis tools where we can check whether or not we have this kind of component. In my experience, when we had systems with a timer, I think we need a timer for our game, some game logic. I don't know which one exactly. And after that, we have well, there was a need for the delayed action component, for example, like call this sort of functionality in some time period. And this timing system was very, like, it wasn't changed, it's just ticked the timer on an entity, and it doesn't know which components does this entity have. So after that, after it has ticked its timer, it removes the timer, and like systems that fire some game functionality, they fire their functionality because they are subscribing to the timer removal, the removal of the timer component, and action calling functionality subscribes on timer removal component, but they are also interested in the action component, for example, something like that. So it's very easy to compose things, to make them work together, to use the stuff that is already working.
One more question about AI. As I remember, it's kind of behavioral complex systems. Well, how is it dealt with in ECS?
Behavior complex?
Well, you have some kind of pseudo AI in your game.
Oh, I see, some sort of third-party system. Like, for example, third-party solution, or?
Like, you have maybe RPG, and you have your squad members, parties, example. So, if these guys you play with, like NPCs, do they have the complex logic in systems or separated in ECS, or how it's made?
Well, for one part, there are quite a few third-party solutions for AI, and it's really easy to hook that up to a working ECS system, where we just treat this third-party solution as a dependency and just talk to it through some public API. And if we need, we put some data from it into our data layer, let's call that. And our own systems can work with that. And what's with implementing AI in ECS? It's a, let's say, a very hot question in the chat. Sometimes, at least once a month, someone asks that, and people start thinking about how it should be really implemented. And some people are sure that each state, like for example, you have a lot of systems that are ticking, just waiting for the new input, and you have an ability to represent any state of some AI agent with a set of components. So for example, if your AI agent has some specific set of components, this system that is responsible for this behavior fires. But of course, you can use more classical approaches with this. So for example, to build a behavior tree, it can also be implemented using ECS2. So you're subpart of some sort of behavioral tree that works with components. Or you can, if you have some very cool object-oriented guy who makes his life, makes his living writing AI using behavioral trees, or some sort of like AI stuff, he can make and write his part of the logic as a separate, let's say, library or separate subsystem. So he implements it like he is used to, and we just hook that up through the public API and put out some data. But it's well, I haven't implemented it myself, just so I know a few people that have, and you can ask them about it. Well, there are actually no problems that can be solved with both approaches, so it can be solved either way. It's just about you making it usable and well, easy to implement and easy to understand.
Imagine if we have some data entities and we have maybe some third-party AI which provide us not the plain data which we can save exactly to disk in memory, and providing some complex objects of that UI. Yeah, and we have to store that objects inside entities, and we lose that ability to save maybe and serialize the data.
Well, it depends on the case. If you don't need, if you need to serialize it, you have to come with some sort of solution. But
have you dealt with this?
I haven't done Well, I have worked with third-party solutions. For example, that game works completely on with Unity physics and Unity View Collider, Unity UI. So physics, we're not simulating physics ourselves. So we treat it as an external data, and we don't actually, in our case, don't need to save it. But I've seen some guys that have also hooked up a playmaker to it and enabled designers to do some visual stuff with it. So it actually depends on the case, and well.
Just sometimes third parties saving just something handlers to inside to the data inside their systems, and
you have to call some functions on it. Yes, and this is where the services and dependencies is state comes into play. We just register some components with it and say that this component points to the third-party entity that works in some way, and we handle it that way in systems.
But then if you want to save the wall state of the game, it can be...
Well, it depends on implementation, I think. Sure. Yes. So if you are if you really want to save it, so and you depend on
if
controlling.
If you want to save your state, you
yes.
will use it in every approach. Then okay, it's not about the ECS itself. It's about serialization.
Yes, it just becomes easier to save a lot of data and to pass it to the server and
the most
so
data you are dealing with is saved easily with this approach. I understand. Okay.
How was Unity integration? So you mentioned that working uses their own engine, which is completely ECS. As I understand, you are using Unity.
I'm using Unity with entities mostly. Yes.
That was entities, yeah. But if the Unity itself has a bit different approach with its components and
well, the question should be rather, why do we use Unity in the first place? Why can't we write our own engine?
Yeah.
Why do we need to use Unity? Why do we need to use for Unity? Yes, and the most interesting part is actually rendering. So the rendering and building process and all the stuff is taken care of us, so we don't need to worry about it. So the best approach would be to treat Unity like a rendering engine and just hook up your ECS world to it. So we have a rendering Unity engine, and we have our small world of ECS, and we just put them together and let them work. So the Unity is just the view, and all the logic happens inside our...
Oh, I see. So you use it in that case? Do you have like some game controller or all this in the...
Well, we still have to hook up the update loop, for example, or we need physics to hook up to the fixed update. So we are usually calling systems in the update loop. So we call systems execute in the update. So we have some sort of a game controller which has a set of systems that need to be executed in this scene. And all it does is just creates those systems and calls updates on them, and that's all.
Am I right that your system is not are inherited from another level?
No, only game controller which needs to listen for the update, and it actually allows to save memory. There was some sort of profiling lately, and Simon Schmidt, the author of the entities, shown that it has some 20 times less memory, and actually it's not the minimum that it can have, because it right now it stores quite a lot of components in the pre-allocated array data, so it can even do better if we are able to do it. But in our case, we use, as I've said, Unity physics too. So we just treat it as an external data, let it simulate, and just check current, for example, current wheel state, current car state. So we depend on external not only rendering but on physics too. So it's also possible to do that.
Okay.
Is that it?
I think that.
Okay, thanks for coming.
Yeah, thank you.